Okay. Somehow last year we managed to do assignment 1 and containers and microkernel all in the lecture. And the tutorial really assumed you had done the microkernel lecture. And I'm dealing with no one to teach CSSE 7023, so I didn't have time to create a new tutorial between yesterday and today. So we're going to do a flying introduction to the microkernel architecture, and then do a flying jump through the tutorial. Okay, so microkernel. It's obviously an architectural pattern. We've looked at monolith, we've looked at layered, we've looked at pipeline, and we've considered how they provide simplicity and modularity. Now we're going to consider extensibility. So, extensibility is all around software that's easy to add to, software that's easy to add new features to over time. And particularly monoliths are famous for the older they are, the harder they are to maintain. And layered and pipeline, how extensible are those things? So, extending a monolith, yeah, it becomes a nightmare soon. Adding new functionality to layered typically means you've got to do something across all the layer, because each of the layers is part of the technology to deliver the functionality, so you've got to work across all the layers. Changing a technology is easier with layers, but adding functionality, eventually not so. Oh, pipeline. Well, that's easy. It's just a new filter. So I can keep adding to pipeline. Pipeline is nice from an extensibility perspective. Another thing we're interested in is interoperability, which is how easily can my software talk to something else? And we can sort of view it both internally and externally. So how easy can it talk between different components within the software, and how easily can it talk to other systems? So, monolith. Well, obviously, internal communication is easy. It's all there. You just use it. Talking to the outside world, not typically so easy. Layered, we've had that nearest neighbor idea. So communicating from one layer to the next, it's designed around that communication process. So yes, it works. Oh, externally, again, it's like monolith. It's just we don't think of things outside of it. Pipeline, internally, again, it's a pipeline. It's just, you've got a standard interface between everything, so communication is easy, and again, it's assuming there is no outside world. So if I want simplicity, extensibility, and interoperability, that's when we think of microkernel. So a microkernel is, as the name implies, there is a kernel. It is called microkernel for a purpose in that the kernel isn't just a massive monolith with a few things on the peripheral. It's meant to be a well-defined, simple, logical core, and then all the interesting stuff is developed as plugins that talk to that core. Now, how do you talk to that core? Well, it depends. Because if you sort of treat it as a monolith, it's all deployed in one application, then communication can be just, I send messages between objects. If it's not, then I need some external communication protocol. But we have lots of standard communication protocols, so that's, again, easy to manage. So one of the things when we get to a complex microkernel is we then start talking about there is a registry. So with the microkernel, you've got the kernel, and you've got the things that it uses, which we typically call the plugins, and you've got the interface between the kernel and the plugins, and then you've got a registry, which is, oh, what plugins do I have? If I've got a half dozen plugins, the core basically knows about them. If I've got a few hundred plugins, I don't want my core to know about them. So we have a separate registry for complex things. We load the plugins. So we've got 3 options. Well, really 2 options. The registry just manages it. You've got static loading and dynamic loading. So static loading is just we launch the application, we load the plugins, and away we go. Dynamic loading is we load them as needed and then presumably can unload them as we don't need them. And this is actually the reason why Java has jar files. That the whole purpose of jar files was so that you could package things up as both deployable and loadable components. So I could package up a jar, fire it across the network, and then someone could run it and then kill it. So what's an example of a microkernel architecture? VS Code, yeah.
A web browser.
A web browser, yeah. So yeah, 2 of our pretty common examples. Eclipse is also another one of the very famous ones. It was intentionally designed as a simple text editor with a plugin architecture. It was a simple microkernel with a plugin, and it's massively extensible because of a very well-designed interface for those plugins. Actually, operating systems. So Unix, Zircon, oh, Nintendo Switch. They're actually all microkernel architectures. WordPress is another microkernel architecture. So it's common. So we've got these plugins. Key principle is the plugins are independent of each other. So a plugin does one thing, doesn't depend on any other plugin, and the only dependency on the core is via the interface to the core, so that we don't have any deep ties between the plugin and the core, or the core and the plugin. There's just one communication pathway. The less intuitive is there's a standard interface. So there should be a single interface defining how my core system uses plugins. Because as soon as I start adding, oh, each plugin has its own custom interface, my core is no longer a microkernel. It's managing a complex plethora of components. So to make this workable in an extensibility perspective, I need a standardized plugin interface. So does plugins equate to a microkernel architecture? Yeah, I just actually said they don't. Oh, and IntelliJ is then actually the example of we've built a really big complex IDE and put plugins. Like, it's really quite useful. Like, it's not a terrible system. It's just they intentionally did not build it as a microkernel. They just used the plugin idea.
Is it born later on?
Sorry?
Did IntelliJ borrow the idea of plugins much later on?
I actually don't know, because I didn't use IntelliJ for years, so I didn't use it early enough to know whether this is something they added later, or it's just they intentionally designed a very sophisticated IDE and said, well, plugins, we're not going to be able to build everything. Don't know. Now, a consequence of the independence principle is that my plugins can't access the core system data. The core system can pass data to the plugin, and the plugin can pass data back, so you can actually get some work done. But anything that needs to be persistent, the plugin, if it has to store anything, has to have its own data persistence mechanism. Doesn't use the core system's persistence. And then we said you could have them for a microkernel architecture can work in a distributed environment. And so you just have some protocol. So we've been talking about REST. So REST would be the simple example. You just have a REST API that you've defined that they can communicate via. An interesting characteristic of this is you can also steal other people's work. And Eclipse does this. So someone has built a service you want to use, and naturally they did not implement your interface. Well, I can then implement an adapter. So this is just the adapter design pattern that implements the interface and then does the translation to the third-party service, and then I can use them. So that's nutshell microkernel. Another point we want to raise is there's a difference between technical and domain partitioning. So the layered architecture is the sort of prototypical example of a technical partition, in that everything is broken up based on a technology. So I've got your standard four-layer architecture. Presentation is one set of technologies you're using. You've got an implementation layer for your logic. You've got a persistence layer for my communication to storage and storage management. And then I've got a database layer, which is the actual persistence management. And so each of these are all technology-based layers. It's all designed around the technology. The nice thing of that is we work with technology. So there's a reason why the layered architecture is common, is because it's the way we think about things. And a lot of applications, that split actually makes a lot of sense because you can then focus on the different technologies and have teams working on different parts of the technology. But the alternative is domain partitioning. So instead of breaking it up by technology, we break it up by what we call problem domains. So things of interest from the functionality perspective. What functionality are we delivering? And so this is vaguely related to the Sahara e-commerce example. I could break it up into a set of domains around product purchasing, product fulfillment, inventory management, customer account management, data mining, and reporting. Yep.
So would each of these domains have a technical partitioning within them?
So yes, would we do that? Possibly. So it's definitely a design option is, each of these domains is going to have a user interface. Each of those domains we can see already talks to a database, and each of these domains has logic. So yeah, that is actually not an uncommon approach.
Or you could create another domain called presentation domain, perhaps. I don't know if that would
Well, yeah, it's not so much the presentation domain, but it would be more I've got something where there's not a whole lot of business logic, and so the domain does its own presentation and talks to the database, and we don't have much of a layering. But layering within it, yeah, definitely something we look at doing. So, is microkernel a technical or domain partitioning? Got one vote for domain. So the core system doesn't care. But if we think of all of the plugins are domains. So again, this is I don't actually have to pick one for my project. It can be, well, the core system is technically partitioned, and then I've got a bunch of plugins which are domains. One of the features we can get of, if I use domain partitioning in the core, it gives me an excuse for having more than one plugin interface, because we can then say each domain has its own interface. And that then says, ah, well, doing these types of things requires certain behaviors, but doing these other things require different behaviors. So we can then say that, well, instead of having just, there's one interface for the entire application, there's one interface per domain. Or in the diagram there, domain 1 and 2 share an interface is an option, but commonly, if I'm thinking of it that way, each domain has its own interface so that we can have adapted, customized behavior. We can have a distributed microkernel. Some plugins are easy to distribute. I can do all sorts of weird and wonderful things, which we're really not going to go into. Like this example of front end, back end are distributed, and then the components in the back end could potentially be distributed as well, or the plugins in the back end could be distributed as well. So that was microkernel in a nutshell. Any questions? This is going to be a test. This is the good news of there is no final exam.
Is this like stuff that you have to know in depth?
Well,
Just sort of like a
cursory. So you might need to know it in depth if the case study you use for your presentation uses microkernel. So you need to know the architecture for your case study in depth. But obviously it's not going to use all the architectures. You're going to need to know the architecture you use for your project in depth, which might be different to the one you do for the presentation. So there's two. But now, in general, you need to be aware of these things and have a vague idea why you might consider it, and that's enough.
You mentioned, like, within the domain, you can have layered architecture.
Yeah.
But, so you can't have the domains themselves layered, right? That goes against what the...
So we don't do layering with like domain 1 and 2 are layer 1, domain 3 and 4 are layer 2, and domain 5 and 6 are in layer 3. No. No, we do it inside the domain. Domain 1 has layers 1, 2, 3. Domain 2 has layers 1, 2, 3, 4. And it could be different layers in your different domains.
Can I ask why not? Is that why there's something?
It just comes down to so we'll talk more about domains later because they're going to become relevant when we talk about microservices, and we're going to talk about them in a bit more depth there. And it comes down to when you're designing a domain, if we then sort of start saying we're going to cluster domains around a layer, we're actually going to be breaking the sort of core principles of what a domain is meant to be able to do. So the idea is a domain is meant to be self-contained.
So domain is like the final packaging.
So the packaging of one part of the functionality of the system. So things like product fulfillment in a e-commerce system. Now that's a major component of the system, but other than knowing what products to ship, it doesn't have a lot of interaction with any other part of the system, and that's what we're trying to achieve with the domain is separation of concerns.
So does that mean the motivation behind the domain is so that we can send off one domain containerizing some software, some host, and then another one and another one?
Okay.
Is that the main motivation, or is that
Well,
the main motivation?
that's actually subsidiary motivation. So a subsidiary motivation is, yes, that, because domains are pretty independent, I can package them up and run them all over the place. The real reason behind it is it simplifies the design of each of these parts of the system, and it loosens the coupling in the system, so it makes the overall system architecture easier to understand. Oh, and we can also then have parallel teams working on different domains, building functionality in parallel. And because there's few dependencies between them, there's fewer communication overheads to do that. So those are all the things we actually want to get out of domain partitioning.